That's enough. And then I got it down, I think all the way to the bottom the second time after I'd been boiled a bit. So you sort of go between boiling yourself. Oh.
That's what I was going to be. Did you hear them doing it after sauna? I'm not sure that was.
Yeah, it's tough to go. The first time I was here, people were like, do that. I'm like, why? That sounds awful. Well, okay, then I'll have to warm up. So, because I can't handle saunas for long. I don't like to be that hot. So, like, okay, well, I'll dump it. Then I can go into the sauna for a little bit.
So some of the activities create problems and then the others solve them.
Exactly.
Right? It's just this interplay between getting hot and cold. And
yeah. What do you like? Hot and cold? Cold and hot? Both? They have a shower that does cold on your head and hot on the sides. Bizarre.
One shower. You get 4 buttons. One button is cool mist. The other one is a tropical storm, and you hear tropical noises and lightning, and it becomes really warm. And there's Caribbean storm.
I am going in doing that.
Good. It's a mixture of cold, hot, and you get bird sounds and smells.
Cold on my head and hot on
why don't they make showers like this? Like in just homes, right? Yeah. Where there's just a whole bunch of features.
Why not?
Right?
Yeah.
Good morning. How are you?
Good. It's a very delicate cable.
Yes, it was like dancing before.
Trying to stabilize it.
Yeah. Little noise at the bottom. It's kind of entrancing to look at.
Oh, that's right, yeah.
It's like glitter. Oh,
I think I got rid of it.
Yeah.
Don't
touch anything yet.
Don't mind us. If anybody else wants to research on your career in Latin monitor theft,
Okay, we'll get there. Write the paper. Good morning.
I didn't notice we have a tree stump in the back.
Isn't it interesting?
Yeah.
I was like, it looks sort of like an elephant to me.
Like they sculpted it just for this room, right? Just to figure out how they could fit it in here.
So they hadn't noticed before, did you? Was the elephant in the room?
Seems like it to me.
Yeah.
I wonder what kind of wood that is. 'Cause it's
I look forward to making even more abominable sounds from this over the next year as well. Anybody who knows how to play Marla on this, please let me know. So it's my very great pleasure to introduce today Amy Jayco to give her keynote talk, 21st Century Grand Challenges in Computing Education. We have been promised that almost every slide will inspire or offend, or both, possibly both. So Amy is an associate professor at the University of Washington Information School and an adjunct associate professor at the Paul G. Allen School of Computer Science and Engineering. She directs the Code and Cognition Lab, where she studies human aspects of programming. But of course, those who know Amy know that she has been working in a number of areas and brings a lot of interdisciplinary knowledge into her computing education. And she's done a lot of work around programming language knowledge, APIs, and programming strategies. And this work has spanned a very, very large number of, sadly, very good papers that I would suggest that you read because her work is very good. So we're privileged to have her with us today. Please join me in welcoming Amy.
All right, let's do a volume test. Can you hear me in the back okay? Is that good? Okay, all right, I'll try to stay right there. Keynotes are an interesting thing, right? We all attend them, we all feel like there are good ones, there are bad ones, but there are actually many different kinds of keynotes too. So when I thought about this, I was thinking about what kinds of keynote do I want to give? And so there are keynotes, for example, that are very much about presenting research. I'm not going to do that today. there are keynotes that are about an outsider coming into a community and sharing their different ideas with you. I'm not really going to do that today either because I'm not really an outsider to this community, although this is the first Coley that I've been to as well, so just an outsider to this space, right? There are also keynotes that are retrospectives that say a bit about what somebody's career was and how they got to where they were. I'm also not going to do that. So what am I going to do? I'm going to fit into this genre. This is sort of a disclaimer slide, but also a framing slide. This is not a scientific talk. This is a political talk about science. So what I want to talk about is which research questions we choose to answer and why we choose those instead of other ones. And the preview here is that I think there are questions that we're not asking that are actually important for us to start thinking about as a community. So that'll be my argument for this talk. Before I provoke you with some of those questions that I think we should be asking, I want to just celebrate our community for a little bit and set up why I think we're positioned well to answer some of these questions. So, this community is just an awesome community. I've been in many, as Nick was mentioning, in human-computer interaction, in software engineering. There's all of these different communities that I've been part of, even programming languages a little bit. And there's something that's really special about ours that makes it one of my favorite to participate in. And it's really that we have collective missions that we work on together. So let's talk about some of these missions that we have worked on over the past several decades. Maybe 1970 to the present. Clearly, one of the big ones has been how do we teach programming effectively? How do we teach it equitably to everybody so that they all succeed? And how do we do it at scale, especially recently with the massive demand that we have, right? These are clear questions that we're all grappling with. Most of what we talked about at this conference and at other conferences are the questions in this collective mission that we have. It's sort of what brings us all together, right? And that's a powerful thing. There are also some more recent grand challenges that we've looked at. Some of them have been things like how do we do equitable and effective teaching of computer science, not just to higher education students, but to really every child in primary and secondary education. This is something that we've really thought about for the past 20 years. It's at a much grander scale than higher education. If you think about the number of higher education students in the world, it's on the order of a couple 100,000. Here we're talking about 30 to 50 million youth around the world at any given time. So it's a very different order of magnitude. And then there's questions like how do we ensure that everyone actually feels welcomed in these learning environments in computing, not just the dominant groups of white and Asian boys and men who tend to be in schools and tend to represent our community. As diverse as ours are, that tends to be who actually participates. So changing that is an interesting challenge and something that requires both research and practice. So I'm committed to working on these problems. I think all three of these are really important. I'm sure all of you are as well. And so it's not that I want to abandon these, but I do think there are other problems that we're not thinking about. So some of these bigger problems, why should we be thinking about them? Partly it's because we have scarce attention, right? When we choose one research project, that means we're not doing another research project. And how many research projects can we really do in the work that we do? It's not actually that many. We might choose a few a year, maybe one a year, depending on our positions and our resources that we have. And so when we make these choices, they're actually very big choices. So we should think very carefully in a proportional way about how much the questions that we choose matter to society and to the world. So some of the problems that are on my mind, maybe they're also on your mind, are things that I think demand our attention. And I want to try to connect these problems to computing education research in this talk. So here's problem number one. It's becoming pretty clear that automation amplified by computing is causing many forms of global economic disruption. In the United States, for example, where I'm from, most of the manufacturing in the United States has disappeared because of things like robotics. We've managed to take jobs that people used to do and found ways of robots doing them instead for much cheaper costs, and that's displaced a lot of the work that's happened in the United States, especially in the Midwestern United States. That kind of economic disruption, as much as we might overcome it over periods of time, takes many decades. It actually causes a lot of challenges, a lot of political strife, just because of that displacement of jobs and the lowering of wages. And I'm afraid that all of this automation, without really thinking about retraining or other types of mechanisms of redirecting people to other kinds of careers could be a very destabilizing thing for society. And this is happening across the world, not just in the United States. All right, problem number 2. This is an uplifting talk, right? They're only going to get worse. Climate change. Regardless of where you stand on it, I'm assuming that pretty much everywhere in the world now, except for the United States, this is just an accepted fact of nature. It's causing real problems, and not just in the future, but today. Mass migration, natural disasters, political upheaval. This is a picture of the 2019 Chennai water crisis. This is what most of Chennai in India is going to look like every single 6 months, every single year, for probably the foreseeable future. This is not a habitable place for people to live anymore because of some of these changes. And this is just a preview of what much of the rest of the world will look like in 50 years, right? So when we think about this, what is the world doing to prevent these problems? And what is our work doing to prevent these problems? And is our work connected to things like climate change and actually trying to mitigate some of the worst effects of some of these things that may already be too late to prevent? All right, so that one was a bit of a downer. Let's see what we have next.
Oh, good.
Yeah,
Better.
just disinformation and the destabilization of democracy. So disinformation, right? Disinformation is when somebody intentionally spreads lies through data and information on social media or other kinds of non-digital platforms. Disinformation is really amplifying a lot of these trends, right? Not only is it related to automation and climate change, but it certainly has its own particular effects on societies. This is a picture of the protests in Hong Kong this year. The government in Hong Kong has spread disinformation to try to cause people to not know where protests are happening, to try to reduce the amount of activism that's actually happening in Hong Kong. Clearly, disinformation has had a big impact on a lot of elections as well, and a lot of votes in various countries where there have been big consequences, right? So here is a great example of something where computing is at the heart of the spread and amplification of all of this information. But what do we do in computing education research to actually think about how to prevent some of these problems? And is it our responsibility to do that? And then finally, one more that's closer to home for me. The consequences of a lot of these problems that we're talking about really fall upon our most marginalized people. This is a picture of a tent city in my home of Seattle. This is where homeless populations often assemble and live and try to get shelter and community with each other to make sure that they can survive in our increasingly expensive city. And this is sort of caused by the rapid growth of all of the technology companies in Seattle, whether it's Amazon or Microsoft or satellite offices of Facebook and Google and Apple. The rapid increase in the cost of living is really driven by the rapid increase in the compensation of software developers that live in the city. This is why housing is expensive, and this is why these tent cities exist. And yet you have companies like Amazon spending millions of dollars on very local city council elections to prevent tax increases on those companies that would actually address some of these problems and compensate for them as well. So it's not just that we're making technologies that amplify some of these problems, but it's actually the companies themselves that we feed engineers into that are actually contributing to some of these problems as well. Is anybody depressed yet? Have things to talk about during the nature walk today? So what do these have to do with computing? Well, I want you to think for just a moment in your own head about the links between the research that we do and these 4 problems that exist. What is our role in actually causing these problems? And if you don't believe that we're causing them, what is our role in reinforcing them or amplifying them? Or maybe, what is our role in just ignoring them, right? And what are the potential opportunities that we have to address them that we're not paying attention to? I would actually argue that our role is pretty central. It's not just peripheral. It's not that we can just be good actors in the broader world, but I think that we're actually right at the center of a lot of these problems, and that it's our responsibility, more than really anybody's, to take action on some of these things. And so that's what I want to convince you of in this talk. So to try to build that bridge, to show you how all of these are related to computing, I'm going to try to explain some of the values that I learned in my computer science education as an undergraduate back in the 90s in a computer science department. So, as a CS major, you might recognize some of these things. I learned that computer science values efficiency over humanity. There's an idea that we learned that automation is always a good thing. If we can automate something, then clearly the world is a better place, right? I think we have enough examples of that, and I'll share some in this talk, where that's actually not the case. Sometimes automation causes harm. Sometimes that automation, just for its own sake, destroys lives in certain cases, right? Of course, I learned later that there are limits to computing, right? There are ways in which, when we automate something, sometimes that actually breaks things. The Boeing crisis, for example, with the 737 MAX, that was an example of something that was just pure automation, where they didn't really think about how pilots would be trained to interact with this automation, and that cost hundreds of lives, just because somebody was ignorant of the role of humans in that automation. So there are limits to what computing can do, and we don't often talk about them. As a CS major, I also learned that computer science really values the power of computing over any notion of sustainability, not just climate change notions, but any sort of notion of what does it mean to have a society that can sustain itself, where there are jobs that people can have that can sustain themselves. We pretend as if computing resources are free, that data is free, that computers are free, but the reality is that none of those things are free. We work really hard to make all of them, and that's not some reality that we really talk about in computer science education. And I learned later, of course, and many of you probably know this, that the choices that we make when we make software have consequences and that we are responsible for them. That responsibility, though, is not something that we actually talk about in practice when we're teaching. I also learned that computer science values neutrality over truth. There's this belief, sort of, that software doesn't have an opinion about the way the world is supposed to work. And the reality is, of course, that all software has an opinion. It has the opinion of the designers that make it. It has the opinion of the developers that implement those opinions. This is what software is. It's an expression of our values. And so I later learned that it's not neutral, right? Software is in no way neutral. The data that goes into it isn't neutral. The algorithms that we design that process that non-neutral data, those are not neutral. They are all very much embedding opinions that we have about the world. And these are the ways that we sort of shape software, and yet we don't talk to students about those realities of those choices that we're making when we make software. And then finally, computer science, I learned, values competition over justice. We sort of pretend in our culture that everything is a meritocracy. When we run admissions, for example, it's very much about, well, let's just choose the people that are succeeding. And we'll use these measurements of success about grades in classes, for example, and just assume that those are really strict and pure measures of how much merit somebody has, as if that's actually what they're measuring. And I think this community knows that oftentimes they're not. Oftentimes they're measuring other things, like resources that people have. So I learned that the world really is not a meritocracy, and that it often reinforces power structures and ignores this diversity of resources that people have in their positioning to learn. Computer science didn't teach me that, of course. It didn't teach me any of those things. I learned all of those things in other classes in college, and sometimes I had to learn them in life and working in an organization. So really, I've come to believe that the values in computer science really reinforce and amplify and contribute to a lot of the world's 21st century grand challenges. All of these issues, right, in some way stem from the sort of narrow culture that we have around how we conceive of computing, and that just translates into a lot of these issues in the world. I'm not saying that computer science is the only discipline that's responsible for these things, but I think it is actually very much and increasingly so at the center of a lot of those issues. Of course, we can change those values, right? Instead of talking to students about prioritizing efficiency at all costs, we can talk about the limits of computing and how sometimes prioritizing efficiency breaks things. Rather than talking about maximizing convenience in the world and having that be the core value of what software does, accept that sometimes software has consequences, and teach our students to accept the responsibility of those consequences. Rather than assuming and framing software as some neutral agent in the world, we can accept that data and algorithms aren't neutral, and that when students design software, they're actually making choices about how the world is going to be structured. And then rather than framing the world as a meritocracy, framing our admissions processes as a meritocracy, accepting and designing for diversity in those processes as well. This is what computer science could look like. This is mostly what it is like right now. Now, I'm not saying that everybody in the room has these values, right? Certainly there's a diversity of perspectives about these things, but I do think that the dominant culture is this, and this one is more rare. So here's my concrete proposal, and the one that I want to go through in this talk. Our most urgent global problems really demand that these 4 ideas are something that all people in the world, not just computer science majors, really have some literacy about. And I want to talk about each of them in turn and try to convince you that they really should be central topics in computer science, but they should also be central topics in what every person in the world learns about computing, not just computer scientists. All right, so I'll spend the rest of the talk going through these 4 and then give a call to action about how we can contribute research to advancing some of these causes. So let's start off with the limits of computing and talk about what I mean when I talk about limits and what are examples of these limits. I think we all agree that computing is powerful, right? That's often why we're most fascinated by it. That's why we want to think about what we can do with it. We think about its expressive power, its power to change the world, and clearly it has changed the world, right? It's powering our commerce, it's powering our social media, it's powering so much of our lives from an infrastructure perspective. But many people believe that the power of computing always makes things better, as if it's this unequivocal good. But the reality is that oftentimes it's not, right? Places like the Consumer Electronics Show paint this utopian picture of technology as always improving our lives. But it never paints the other side of that picture, where it actually harms lives and makes things worse. So here are a few examples. In the United States recently, there was a software company that decided to help judges make sentencing decisions about how long somebody should stay in jail, in prison. And in automating this, the hope was that they would be more objective than judges, right? Now, what's happened now is that judges are not just using this as guidance, but they're actually letting these algorithms make decisions on their behalf. They're just taking the output of the algorithms and then deciding somebody's fate based on the algorithm's output. Why do they do this? It's because of this blind faith in computing being always good and always right and always correct, right? People don't understand, judges don't understand, that this is a garbage in, garbage out process. If that data is wrong, the sentencing recommendations are wrong. And so what's happened is that because in the United States, it tends to be that Black Americans tend to recommit crimes more often than white Americans, there is a bias in that algorithmic data set for this machine learned prediction that says that, well, Black people are just more likely to recommit, so all Black people should be sentenced more and for longer, which only really amplifies that past rather than changing the future. Here's another example. If you look at the Paris Climate Agreement, people use faith in technology to always solve problems as an excuse for not considering stronger policy changes that would actually address climate change. I went through and read the Paris Climate Agreement, and inside it you'll find all of these statements inside that say, under these assumptions, this is what the future could look like if we meet these goals. What are the assumptions? The assumptions are that technology will resolve and fix about 80% of carbon output in the next 30 years. Do you believe that as computer scientists, right? As people who might be responsible for educating the students who are going to make those changes? Do we think that 80% of that carbon output will be reduced by algorithms, right? Will be reduced by other kinds of STEM technologies? Maybe some, but probably not 80%. And it's because of that 80% that this climate change agreement does not involve stricter policy recommendations. Again, it's that faith in the power of computing that's a barrier to those policy changes. This is Mark Zuckerberg testifying in Congress in this past year in the United States. He was recently called to testify about disinformation and censorship. And he expressed this core belief that Facebook was neutral and could be sort of a neutral arbiter of what information appears on Facebook. And then at the very same time, he expressed faith that automation could also censor disinformation at the same time. So how can Facebook be both entirely neutral and also use algorithms to sort of address censorship in a non-neutral way, right? These are sort of two beliefs that are entertained at the same time. The reality, of course, is that Facebook doesn't even use automation to do this censorship. It has a team of hundreds of people that take individual cases around information that's posted on Facebook, and they make decisions that are based on policy judgments that Facebook itself has made that we don't get to see and we don't get to control. So in some ways, the power of computing and the faith in that power of computing has concentrated power in media companies like Facebook. And we just let it happen because we have that belief that algorithms are good. One more example. Developers like to talk about software as solving social problems, right? Here's an example of one that solves homelessness in Los Angeles, in the United States. This is the idea that you can get a mobile app and it will somehow make people have a home, right? How does that happen exactly? Well, it turns out that this application, the mobile app that they launched here, really all it does is automate some matchmaking process between somebody who needs a home and landlords who are offering homes. Why is it that those landlords would want to offer those homes to those homeless people, especially if they have no money? Well, it's because the California state government has set aside $30 million to subsidize people getting those homes, right? All this app is doing is just making that connection between those two people. The thing that's actually doing the work is the $30 million, right? But that's not on their website. That's not actually the thing that's prominent here. The fact that the state government put aside that money, what's prominent here is that there is an app and it is going to save the world. It's going to make people have homes. Again, blind faith in the power of computing, preventing people from understanding that the real thing that was making change was money. So everybody needs to know these things about the world, that software is often wrong, that it's not neutral, that it's not free, and that it can't solve every problem in the world, right? We don't teach our computer science majors this, and we certainly don't teach everybody else in public education these same ideas. These are sort of absent from that conversation. Now, if everybody knew these limits, judges and driverless car users might have less faith in technology and algorithms to make autonomous decisions. We might actually ask for more responsibility for the people who design them. The public might be more skeptical that technology alone will save us from climate change. Consumers might be more mindful of the price others are paying for the free internet and the free speech that happens on a lot of media platforms. And developers might spend a lot less time trying to make mobile apps to solve social problems and a lot more time just solving social problems. Now, you might think that teaching people to code might teach them these things. I would argue that teaching everyone to code really only strengthens belief in the power of computing. When people learn to program, they come to believe that programming is this powerful medium, right? This is why we enjoy it. And that programmers are powerful wizards who can do anything with code, right? I know my experience around learning to program was I felt powerful after I did it. I could create things that other people couldn't create, right? That's part of why we're excited about doing it. But they learned nothing about what programs can't do, only that smart people can make computers do anything. So we extrapolate from that and assume that smart people can make computers do anything like solve social problems. Clearly, we have no idea how to teach any of these ideas. How do we teach the limits of computing that actually transfers to people's everyday lives and choices about how they interact with computing? How do we integrate them into primary, secondary, and post-secondary education? And how do we prepare teachers to teach all of those concepts as well? Right? These are entirely open questions. We really don't know how to do most of these things. We're just starting the conversation around how to integrate some of these subjects into higher education, and that's it. So we need to teach people the power of computing, but also its limits. But we also need to teach them responsibility, right? And what their social responsibilities are. This is a picture of Election Day in the United States. Why do people vote? Is it because they believe their vote will have an effect on an election? Often not. Sometimes they just do it because they know it's their duty as a citizen, right? We often give each other things in society, not because it's out of self-interest, but because it's our responsibility. That's sort of missing right now from computer science. When we teach computer science, it's often agnostic to what it is that students make. We focus on programming, but we don't focus on what people do with it. We don't talk about what they might build and what companies they might work for. We focus on whatever students might be interested in, right? Rather than actually trying to shape their interests. They come to us and say they want to make games, they want to make apps, they want jobs, they want money. When do we have a conversation with them about which games and which apps and which jobs and what kind of money and from whom? Right? Those are absent from a lot of the education that we do. So clearly things matter about those choices, right? Here's a student that's chosen to study climate change in a science fair rather than building a robot. Which one will have more of an effect on climate change as she grows up and makes choices about what to do with her time? When students become developers, what ethical stands are they willing to take against automation that they are willing to stand up and fight for? Here's an example of a recent letter that a bunch of Google employees wrote against the censoring Chinese search engine called Dragonfly. I think there were about 600 Google employees that signed this, and it circulated and had some impact on what Google's choices were about whether to do this. Why was it only 600 Google engineers? Why not all 15,000? Right? What stopped those 15,000 engineers from standing up and saying, yeah, I'll put my name on this. I don't want censorship to happen in China. I stand against this. Was it their values, or was it just their fear of actually taking that stand? And what could we have done to actually give them some confidence in actually making that stand? Here's a picture of a job fair at Stanford, in Palo Alto, in Silicon Valley. Look at the companies that are represented here. Who's hiring? We have financial companies like Visa. We have media companies like Hulu. We have retailers like Amazon. Where are the green energy startups in this job fair? Where are the anti-poverty nonprofits? Where are the government organizations, all of whom are in desperate need of software engineers to create their digital infrastructure, just as much as these companies are, right? Where's the conversation with students about all of those other opportunities that exist in the world? Really what we're doing is we're just letting people that have money to recruit come to these fairs and recruit. What are we doing to actually spend our time and resources to find all of those other companies that don't have money to recruit, to help them find engineers and develop a passion in students for working for those companies as well? And lastly, what choices do students make about what to create? This is a map, for example, of all of the counties in the United States that no longer have a local newspaper. Why have all of these newspapers disappeared, right? In some ways, it's actually because of social media, right? People can get quote-unquote news now for free on social media from their friends, and so they don't rely on newspapers anymore as well. Our students are choosing to go to those social media companies and amplify this problem further, rather than going and working for newspapers and helping them find sustainable business models to regrow sources of ethical journalism. So why do students ignore these problems? Well, wealthy companies are better at recruiting, but we do little to show them the alternatives. Students want to work on new technology, but we rarely talk about applications outside of consumer technology, the ones that students are familiar with. Students value sometimes wealth and status, but we rarely attempt to actually change their values and tell them that there are other things they could value. And they look to us to actually decide what to value in many cases. So what should we be teaching? Well, we should be helping students understand that the problems they choose to work on will shape the world. And the problems they choose not to work on won't be solved. Where they choose to work will determine the problems that they work on, right? Their choice of organization, or even their choice to make a new organization in an entrepreneurial way, that determines what problems get addressed. And to make these choices, we actually have to help them develop their values and their ethics, and their entrepreneurial skills, potentially, if companies don't exist that are addressing these things. These are not things that, in general, we help them to do in meaningful ways. Now, if they knew these things, some of the world might be different. We might have products and services that augment our abilities rather than trying to replace them with robots. We might have more products and services that address climate change, right, than more social media companies and more food delivery services. We might have a more robust free press and stable democracy because people will be investing in actually making things that reinforce those values rather than ones that amplify the opposite. And we might have more effective public and private services, right? If I could have all of my students in my undergraduate program graduate and work for my local city government would be a lot more efficient and a lot better, but they don't work for them, right, for many reasons. Again, what if we teach everybody to code? Will that help any of these things? Again, I would argue not. Educating great programmers will not teach them social responsibility. When people learn to program, they come to believe that programming is about puzzle solving, not social change, right? Even though that's exactly what they're doing when they make software. They're determining how our social worlds work. They also come to believe that developers' responsibility is purely technical because those are the only terms in which we talk about programming and not a social context. So they learn nothing about the role that software developers play in shaping our products, our services, our governments, and our communities. These are just sort of absent ideas in their mind. Maybe after 10 years of working in industry, they start to come to realize their role in some of these things and change their minds. Many of my friends who work in the software industry have, and it's a very consistent decade-long process of them making these discoveries about their contributions. Again, we don't know how to teach these things yet. How do we convince students they're responsible for their technical and career decisions? How do we prepare them to be socially responsible across their lifespan in the choices that they make, in what they make, and the careers they choose? And how do we empower them to change the companies that exist if they're not happy with the companies that do exist, right? Entrepreneurship is really central to some of these things. It's a powerful force for social change because it changes the types of organizations that exist. All right, so everybody should know the limits of computing. All of our graduates, and certainly everybody else in the world, should have some sense of their responsibility to exploit the powers of computing for good and think about their limits at the same time. Why data literacy? Why does this matter, and what does it have to do with computer science? This is a picture of a very, very boring database schema for an e-commerce site, right? So when I say data literacy, I literally do mean boring things like this. And so what I try to do to make things like this more interesting when I'm teaching undergraduates is I'll show them a picture like this. Here's Google and some search results, and here's Google without data. Where's the power in Google? Is it the algorithm? Is it the indexing? Is it the crawlers? Is it all of the things that we automate with computing at Google? Or is it really all of that content that people have created in the world that's valuable, right? This is meant to really illustrate that we don't point out to students that really the powerful thing about computing in most cases is the data, is the information, is the content that moves through all of the algorithms that they're writing. It's not so much the algorithms themselves. If the content wasn't there, the companies wouldn't exist. They wouldn't make money, they wouldn't have profits, there would be no jobs. If the algorithms aren't there, things are just a little bit slower. That's basically what contribution computing is making to many of these different contexts. So students should know, what is data? Where does it come from? Why is it powerful? How does it do harm? There are examples like all of the powers of data. When people think of Facebook, they think of the apps, the internet, the newsfeed algorithms, not the content that billions of people are giving Facebook for free and that Facebook makes valuable by monetizing, right? That's a perspective on algorithms that most students don't have. When people learn about machine learning, they learn of algorithms. They learn of powerful statistical techniques for making inferences, right? They don't learn about the data required to actually power those algorithms and what it takes to produce and maintain and repair all of that data. And yet the data is the thing that actually drives all of that. If the data doesn't exist, none of this happens. Again, our students don't think about data as being that powerful unit that powers computing. Of course, data is central to computing, and it's often a source of harm that is caused by computing, which is why it's central to understanding the limits of computing. Here's an example. Facial recognition data sets have really severe race and gender biases, but law enforcement in the United States is using them anyway, right? So it turns out, for example, that Microsoft research found that there's a consistent underperformance of dark-skinned women in these racial data sets. And so you're much more likely to be misclassified as one person who you're not if you are a woman and if you have dark skin. That means that if you're using this in law enforcement context, this is just going to result in more arrests that are unfounded and of the wrong person than if you're white. So everybody needs to understand that these are garbage in, garbage out processes, right? The data determines whether these are good. It's not the algorithms that really do. Here's another example about the importance of data. It's really humanity's hunger for data and not algorithms that's driving the massive power consumption in the world's data centers. If you plot, for example, the amount of carbon output in the world and the contributions of that from data centers, it went from being about 0% 15 years ago to being about 6% of the world's carbon output in the past 15 years. So data centers and our hunger for data and our hunger for information, that's driving a lot of the increases in carbon output in the world. But we don't really teach students to think about the fact that these invisible things that we don't visit and we don't see really are a massive source of contributions to climate change. Social media companies have quickly learned that disinformation has all kinds of negative effects, and we don't talk about them. People can die because of disinformation. People are bullied. People are violated. Democracies are destabilized. There's power in information, and yet when we teach about data in computer science, we often talk about it as having no particular purpose or meaning. It's just abstract. It's just numbers. It's just text strings. It's just symbols. This is a picture from an airport body scanner where metadata is used in machine learned models that reinforce invalid models of gender leading to harassment. As a trans woman, every single time I go through the airport, the TSA agent presses a male or female button depending on how they believe I present. And it doesn't really matter which one they present because all of their efforts to try to detect what is an anomaly on somebody's body results in me always being marked as anomalous. Which means every single time I go through, I'm basically sexually harassed by somebody, and it's just a question of which way I'm harassed, on the top or bottom of my body. And that's just because of data, right? Some model of what a normal male body is or a normal female body is, that's the thing that actually shapes whether or not that happens to me and how. So everybody needs to understand that data is an imperfect record. It can often be entirely wrong, right? Data is always about the past. It's never about the future. That's another limitation of data. Data is always biased. It always encodes the values of the people who captured it, right? All of these things about data that we sort of assume are some given property of them, that data just comes for free. These are not things that are free at all. These are things that are shaped by processes and structures that have social biases embedded in them. So if our students knew these things about data, we might stop developers from using biased, incorrect, and unrepresentative data to automate the world. We might reduce people's faith in machine learning to solve every single problem in the world, nudging them towards policy solutions instead. We might grow demand for better data privacy rights, like next versions of the GDPR, for example. And we might prevent computing from amplifying all of the bias in the world, right, and actually just leading to change in the world instead. You can't actually change the world by relying on records from the past and how the world worked in history. Do you think that teaching everybody to code will teach these things? Again, probably not. When we learn to program, students come to believe that data is abstract, free of values, free of meaning, and free in general. It just comes out of nowhere, right, magically. The instructor just gives it to you and it exists. Nobody had to make it. And that algorithms are the primary lever of computation and not data, as opposed to the reverse. So data becomes this very insignificant thing in computer science that we just sort of take for granted. They learn nothing about what data is, how it's limited, how algorithms can amplify the harm that data can do to people in the world. These are not part of our conversations. And so again, how do we teach the limits of data in a way that transfer to decisions in everyday life and in software engineering contexts? These are things that we need people to enact while they're making implementation decisions, when they're making software, but also while they're using software and deciding what software to use. And how do we integrate ideas about data into primary, secondary, and post-secondary education? What is the sequence of understanding of somebody's growth in the world and integration into society about what the role of data is in their life? And then how do we prepare teachers to do all of these things? What is content knowledge around data literacy that teachers need? And how do we help them teach all of these subjects? And lastly, designing for diversity and literacy about diversity. I've discussed these three major ways that we might reshape what people think about in computing. And I want to argue that what underlies all of them is actually questions about diversity. So let me just define this briefly. For those of you who might think that this is some scary, dangerous word that leads to difficult conversations, it's actually not that complicated. Diversity is just a fact of nature and a fact of society. We're all different in all kinds of ways, on many dimensions. That's all diversity is. But it's a fact that's often just ignored in the design of software, for often good reasons for the medium. But it's also a fact that's at the foundation of those three areas of knowledge around the limits of computing and social responsibility and data literacy. So let's unpack each of those. So what does diversity have to do with the limits of computing? Well, automation, in some sense, when we talk about algorithms, it can work great for really normal contexts, typical cases, average cases, right? That's what we design algorithms to do. That's what we build software for. The middle of that distribution, that's what we get right? We often don't spend as much time when we're teaching programming to deal with edge cases and error handling and unexpected inputs. We talk about that being important. We talk about the robustness of that, but it's not something that we really spend a lot of time teaching about, right? But diversity, just as a fact of nature and a fact of society, guarantees that most of those cases that we have to deal with are not normal. Most of them are not the typical, right? Even though each individual kind of diversity might be rare in its own way, it's actually not something, when you add them all up, that is minority. It's a majority minority, right? Most cases are atypical. So whether it's a deterministic algorithm or a data-driven probabilistic reasoning behind some machine learning, software is going to struggle with diversity, and students don't recognize this, right? If you aren't aware of that diversity, you don't design for it. Second, diversity increases social responsibility in some surprising ways. So where does responsibility come from, right? Partly it comes from power in society. And when a discipline like computer science disrupts every facet of society and positions itself as the center of most parts of society, that means that computer science has power and therefore responsibility, right? Responsibility for everything and everyone for which computing is the foundation. Our students don't recognize that computing plays that role in society. They don't recognize the power that they have, and so they don't take responsibility for it. And we're just as culpable in that because we don't tell them that they have that power, and we don't tell them that they have that responsibility. We tell them that software is neutral and it's not their fault. And then finally, data literacy really is the same thing as diversity literacy. Data can do harm precisely because of diversity. It's bias in data, disinformation, data privacy issues, they're all fundamentally about who is represented by data and how that data about them is used and for what. And our students really don't comprehend that the true meaning of a bit isn't just 1 or 0, right? But the true meaning of a bit is a person, an identity, some fact of some action in society that's taken. And that all of those meanings can actually entrench power, that they can warp society, and that they can destroy lives just as much as they can change lives for the better, right? Well, all of those outcomes are possible. But we don't tell students what a bit means. And so every student needs to know that it's because of diversity that computing is limited. It's because of diversity that they're responsible for wielding its power carefully. And because of diversity that data actually does harm in the world. Right? And so if developers are going to ignore diversity, they're ignoring a central property of software as a medium and as a tool for change in the world. If developers knew all of these things, they might seriously consider not automating something because there are good reasons not to automate it. They might choose projects that help everybody in the world rather than people that are like them or certain groups that are willing to pay for some product. They might acknowledge that the power that they have really is the power to make or break democracy. That's where we are in society these days. And developers might recognize that the world is far more complicated than they ever thought, and that might humble them. That might make them recognize that maybe they don't know everything, and maybe computing actually can't fix everything. So does teaching programming teach these things? I think you know the answer by now, at least my answer. Not really, right? When people learn to program, we teach them that simple average cases for highly abstracted problems are the thing to pay attention to. That's the central thing that they need to know. That good design is a computational matter, not a social one, right? It's about making good technical decisions, not about making good design decisions. They learn nothing about the diversity of humanity, the diversity in society. They don't learn about how software design choices interact with this diversity. Most of academic CS really doesn't even view these as part of computer science, right? And that's really what I'm asking you to do, is view them as part of computer science and as part of what people need to know about computing. So how do we teach diversity in the context of computing in a way that actually transfers to these choices that students are making when they work in industry? How do we prepare developers to design for outliers instead of averages? And how do we prepare teachers to talk about these things as well, right? It's just as important to get them, probably more important, to get them to understand these than students. And so it's our job as really computing education researchers to answer a lot of these questions and teach those answers to everybody across the planet. So I'll end with a brief call to action, and then we'll have some time for questions. There's 4 things I think are missing from what we teach about computing, not just to computer science majors, but to anybody learning about computing, and that includes all youth. And I've really argued that teaching them could reduce a lot of the harms and a lot of the problems that are facing in the next century. So now I want to convince you that it's our responsibility as a community to actually address some of these things. So I'll remind you that our community is awesome, right? We know how to tackle big problems together. We take on big missions all the time. We know how to work on problems that matter to CS. I'm just arguing that we don't know how to work on problems that matter to the world, right? It's those bigger problems, the ones that we're sort of ignoring. And I'm asking you to feel responsible for tackling those. And so let's talk about what we've been doing and what we could be doing. Here's what we talked about in COLI 2018. Programming, right? Better ways of teaching it. Better ways of understanding what students think about it. Describing and critiquing curricula. Assessing programming knowledge. I am culpable in all of this, right? I've published in all of these areas. All of you have too. This is what we do right now, right? It's what we've talked about this year as well, although we're getting smarter about it. We're thinking about research skills, we're thinking about replication, but we're also doing these other topics. I would love if COLI next year was something more like this. How do we teach the limits of computing to students? And when and where and how? What are effective ways of teaching social responsibility? How do we teach data literacy in the context of all of these subjects? How do we integrate all of these topics into our curricula? How do we assess this knowledge and how it is related to all of the other knowledge that we want students to know? And how do we know how programming affects the above? I have pretty strong hypotheses that it just makes all of these worse, but somebody should test those, right? I think maybe I'll test some of them soon too. These are our computing education grand challenges for the 21st century. I think they're our responsibility, and we should get started now. I think we're the only community that can actually do this because we're the only ones positioned to change what is taught and how it's taught well. This is our social responsibility. Thank you.
I do love it when the keynote speaker gives a really strong direction to the incoming chair. No challenge accepted. Thank you very much for a fascinating talk, as promised. Very, very thought-provoking. So I'm going to throw the floor open because I'm sure there are questions, and we do have a good amount of time for questions. Who'd like to go first? Sten.
Hello, thank you for the talk. I'm Sten from Estonia, and I'm also really interested in these ethical matters. And I really found this example of Google without data quite powerful. Do you have some other examples, something like that you can share?
Yes, many examples. One thing I didn't say in this talk, this is examples about sort of the power of these perspectives, is that in the school that I teach in, it's not a computer science department, it's the information school, most of what we teach is about these things, right? It's a really central topic. I think it's great that we do that. I think all of our classes are full of many examples. Our students graduate with them. They're just less than 1% of the people who become software developers in the world, and so they're a tiny fraction. So computing education is really the big group. So examples are things like in our databases class, right? We have a whole 2-week module that's about the design of database schemas, and not just the structuring of those schemas and how they're translated into database implementations and how they have performance implications, right, which is very much just about efficiency, but what are the social implications of database schema choices that you make, right? I'll go back to gender since I brought it up, right? When you make a database schema and you choose that gender is binary and somebody does not identify as a binary gender, you are explicitly excluding them from being represented in that database, right? So we talk about issues like that and how that's really a very innocuous choice you can make from a technical decision that has profound implications in a social context.
Yeah, I believe that one solution is not that we would just have a compulsory computer ethics course, but this needs to be integrated in many topics. So, what is your guidance of this integration in various topics?
I think the question here is about required course or integration. I think this is a very big conversation that many computer science departments are having, and it's certainly a question that I think we're thinking about in primary and secondary contexts as well. I actually think in some ways that neither of those solutions go deep enough, right? Day one, when you talk to students about what an algorithm is, how do we define what an algorithm is? We often say things like it's a procedure for taking some instructions and computing something, right? Why isn't there a definition of an algorithm? Something that takes some process in the world and has a machine do it instead of a person, right? And takes some data from the world that's a record of the past and tries to process it in some way that's used as output for somebody else, right? That is missing from even that foundational concept of what an algorithm is. So building in notions of these things into the very foundations of how we conceptualize what computer science is, that would actually position it not just as integration, where there's a module added onto a course, or not just as a required course where it's the place where these things are discussed, but rather every single concept that we talk about, reconceptualizing it in some of these terms, that's where I think it really changes how people think about it and use those ideas.
If I could follow up on that immediately, one of the people always ask why I keep coming to Finland. They assume I have a second family. I honestly don't. But one of the reasons is, of course, that the cultural contextualization for the value of education is not disputed. How much impact do you think a local culture is going to have on our ability to carry out the kind of transformation you're thinking about?
I think that the interactions are profound, right? Even just trying to persuade students that some of these ideas matter, these are sometimes in tension with culture. Certainly I can speak from the context of the United States. In some places in the United States, none of these ideas would be accepted at all. It would be completely rejected. All of them would be viewed as false, right? They wouldn't even be accepted as sort of a reality of the way the world works. Whereas in others, they would be fully embraced, and then there would just be a lot of arguments about how to implement them, and then we would never get anywhere, right? So when I think about how this will actually play out, these are going to be hard conversations. I don't think that I expect rapid change in any context, but I do think that every local context and its culture is going to have to find a way through some of these implications, because we'll have our own ways of interpreting and integrating these ideas into the way that we see all of these concepts.
Thank you. Who else? I think you were next.
Yeah, also as a follow-up, I think we, for example, in our curriculum, we do have ethical courses, but I think when they are taught in separate ways, students tend to, overlook. I think it's to be more powerful that, as you said, that we integrate with the actual courses. So, for example, what you say, if you have some, let's say, machine learning course, usually the teacher prepares the data sets so that the nice outcome comes out, right? But what if you prepare a data set so that the bad things come? Then you would do the stuff and see, okay, this can go wrong, and then you actually felt it when you implement.
That's a great example. I'll bring up one related example to that. I have a colleague who teaches natural language processing in computer science at the University of Washington, and just by an accident of history, disability is a really central topic on campus. We've had lots of great leadership in that space, and it's led to a lot of awareness. And so when he was working on a module for teaching sort of really challenging NLP problems, he took speech from deaf people, and the entire sample was deaf people. And so deaf people, if you don't know, right, sometimes they can speak well enough that people can comprehend them, even though they can't hear their own speech, or they can only partially hear it. It's very challenging speech to understand, right? So the test cases there are not what works well for the average speaker, but what works well for the worst possible case of speech. That's where computer science gets really hard, gets really interesting, gets really challenging. Dealing with those edge cases really stresses the quality of that classifier that they're using. That's a kind of integration there where it's not just about adding on some module about diversity in that setting, but saying what computer science is taking the really, really hard data sets and making them work for that, not making them work for the average case.
Thank you. Other questions? Right at the back. Thank you.
Hi, this is Guru from Japan. Thank you very much for this very nice keynote. There is a popular quote that's going on in autonomous driving. People they say, well, the cars don't need to be perfect, they just need to be better than human beings. And probably we could say the same thing about algorithms in the cloud. Maybe they just need to be better than human beings. For example, for the judges you gave the example, did anyone study if, like, the report of the judges, if, like, in the past, how they judge, like, black women compared to how they judge white women, if, like, those applicants with the judges?
It's a fascinating question. I don't know if anybody's done that study, but I can say that such studies are highly fraught, right? If you were to try to measure whether or not a judge or an algorithm was better at predicting somebody's future, that's highly, there's a feedback loop there that highly confounds whether or not that outcome happens, right? When a person's being judged by an algorithm, how does that influence their likelihood of committing a crime in the future, right? How does that change their sense of justice in our country, right? How does it actually make them feel like they're being judged fairly? If they go to prison and feel like they weren't judged fairly and then they get out, how does that change their relationship to society? So there isn't an easy way of actually measuring and judging the quality of things. And I think I'll state more broadly that notions that all we have to do is measure quality, measure error rates, measure efficiency, these are very reductive notions of whether or not something is good, right? They're very engineering-oriented notions of whether or not something is good. How about we talk about, in addition to efficiency and correctness, which are very much engineering ideas, we also talk about whether or not those decisions are just. They are judges, after all, trying to enact justice, right? It seems more reasonable to actually have a conversation about which one is more just.
Also, I noticed you talked about misinformation instead of fake news. Is it because you don't want to be associated with your president?
The academic community that has been studying disinformation for 50 years has always called it disinformation. Fake news was a phrase that our president invented, right? And so we're following the scholarly discourse and not our president. So.
I just wanted to speak briefly to the judge one because there's a disputed study about parole board judges in Israel. And if you plot the decision-making process, when they get hungry, they stop granting parole. Now, there's a lot of discussion about whether this is in fact a true and accurate measure, and it will not be done anytime soon. But in terms of fairness, the idea that hunger is enough to throw humans off, that's been used as an argument to support the machine. But of course, giving over everything to it on the idea that it's a perfect oracle, it's more than flawed. But it's a study. If you look for Israeli parole board study, you'll see it.
Whereas a justice argument, right, for that is very much about saying, what does an aggregate distribution of prior behavior have to do with an individual?
Yeah.
And if you think about justice in a philosophical lens, you might conclude that it actually has nothing to do with that individual. It doesn't matter what anybody else in society has done or will do. All that matters is that you're treating the individual and their case.
Are we advocating Minority Report now as educational reading? Sorry, I think you were first to just up with that, Ollie.
Sorry, just very, very briefly to expand on that, actually. In the UK, the conditions that put people when they come out of prison by their probation officers is now, we shouldn't really give them right to a probation officer, as of the last week, they're now setting the conditions that they have to abide by machine learning, by artificial intelligence, rather than the probation officer, which means it's not just necessarily, as in the States, where the impact upon that person how they're going to move forward with their potential criminal career. There's actually the potential impact on other people, because it could be that the probation officer might think sex offender A shouldn't be in this area. The algorithm disagrees with that, so the person can go where they like, and the entire nation's now at risk as well. So it is an expanding problem.
Yeah, and you get to these questions about who decides, and who can decide fairly, and who do we trust to decide, right? Once you start unpacking that conversation around justice and who's responsible and who can be fair in some of these things, it's really only the faith that computers and algorithms and data are impartial and neutral that leads us to go to those solutions. And it's the lack of literacy about the non-neutrality of algorithms that makes people believe that they actually are neutral, and in fact they're not neutral at all. They just represent history, right? So what we should really be saying, and what we could be saying if everybody knew these things, is that algorithms are about history. So what's more just, using history to decide somebody's fate, or using an individual's judgment to decide their fate?
Oh, I have a green thing. Please carry on. Right, if someone can pass that forward. Thank you.
Okay. Thank you for the really nice and eye-opening talk. I actually don't have a question. Something to say that I wanted to tell you in person.
Yeah.
I think now that the discussion is going this way, it affects everybody. So I study machine learning. That's my thing. And you focused more or less on this non-neutrality caused by data. But there is a lot of it coming from the algorithm developers that I would have wanted to see that. And very briefly I will mention, you said garbage in, garbage out, so this is data related. But there is a branch that studies outlier removal methods. You will find a bunch of these. Choosing which outlier removal method you will use is a choice that the algorithm designer is going to make. And also, one person's trash is another person's treasure. So who chooses what the outliers are? Are they good or bad? Do you keep the information? And then moving to the features they use, selecting the features is a subject process. In law, maybe you could escape and put all possible features, like have a complete feature set, but then you have the question, how do you scale the features? How you normalize the features? And often you have text data, but computers like numbers. So how do you do the conversion from text into numbers is another decision that somebody has to take. And finally, choice of the classifier. All of these are choices by the developer. They have nothing to do with the data. So even assuming the data is correct, and by the way, all these choices don't end up